In the second PowerPoint, we're going to look at chromosomes and how they're organized in the cell. Remember what we talked about in the previous PowerPoint? DNA in the cell normally is not easily seen. The DNA is unwound so that chemicals can access the bases. When DNA is visible, and it looks like this on the right, it has already made an exact copy of itself. We never normally see single chromosomes by themselves because when they're in that single state, the DNA is so widely spread out that it's not actually visible. When we can see it, it's copied itself prior to cell division, so that one copy can go into one cell and one copy can go into the other cell. We call these sides chromatids. So here is a chromosome that's made an exact copy of itself. So it's got the exact same genes in the exact same place, and the bit in the middle here is called the centromere. So how many chromosomes do we have? Well, firstly, each one of these chromosomes is in that copied state, and we have 2 copies of each chromosome. Humans have 23 chromosome pairs, or more accurately, 22 pairs and 2 sex chromosomes. A girl will have 2 X chromosomes, and a boy will have an X and a Y. There's nothing magical or special about the number of chromosomes, though they are specific to a species. To be a cat requires 18 pairs of chromosomes and the 2 sex chromosomes, but to be a crab-eating rat requires 90 pairs of chromosomes and 2 sex chromosomes. So there is no real significance to our 46 chromosomes that humans have, except that humans have 46 chromosomes, 22 pairs and 2 sex chromosomes. So where did all these chromosomes come from? Well, remember, a zygote is the first cell of a new organism, and we all began as a single fertilized cell or zygote. The DNA in that zygote, that very first cell of you, came from the sperm and the egg. The sperm brought 22 chromosomes and an X or a Y. The egg had 22 chromosomes and an X chromosome. So to be a human requires 46 chromosomes, 2 sets, numbers 1 to 22 and an X, and numbers 1 to 22 and an X or a Y, depending on if you're a boy or a girl. So in a normal body cell then, there are 2 copies of every chromosome, one from the egg and chromosome 1 from the sperm, chromosome 2 from the egg and chromosome 2 from the sperm, all the way up to chromosome 22 from the egg and 22 from the sperm, and then 2 X chromosomes, 1 from each gamete, either XX or XY. And remember here that these chromosomes have already copied themselves just prior to cell division. We call these 2 copies of the same chromosome, 2 copies of chromosome 1, homologous pairs. Homo meaning same, logos meaning writing. And we mean by that they have the same genes as you go down the DNA. They'll be the same shape and the same size, and they'll have the same genes, but they may have different versions of those genes, different alleles. So the hair color gene will be here, the hair color gene will be here. Tongue rolling gene will be here, tongue rolling gene will be here. But this version of hair color gene may code for black hair, and this version or allele of the hair color gene may code for blonde. Same genes, but maybe different versions on the homologous pairs. So just remember, a gene is a short section of a chromosome that codes for a characteristic. And these big words show disease genes where a gene has not got the right base order, and then as a result, this section of the chromosome codes for a disease state. There are 20,000 genes spread across your 23 chromosomes, so each chromosome will have hundreds and hundreds of genes. So just to restate, here's a chromosome, and it's just copied itself prior to cell division, and here's its homologous pair, and they will have the same genes in the same place on those chromosomes, but they may be different alleles, different versions of that gene. We're going to look at genes and alleles in the next PowerPoint.